So we're going to take a look at a couple of sample problems from the ALEX program that'll go with your concept check. So before you start your concept check, hopefully you're taking a look at this video to kind of help elaborate on some of the things you saw on the 2.6 notes. So this says, translate each graph as shown below. So part A says the graph of y equals f of x is shown. Translate it to get the graph of y equals f of x plus 2. So if you remember from the 2.6 notes, when we see a constant added to the x inside or embedded in the function like this, we are dealing with a horizontal shift. So this is going to be a horizontal shift, and we talked about this in the video in 2.6 that an addition in the horizontal shift is actually going to be a movement to the left. So this is going to be left 2. So for this particular absolute value function here that they have, we're essentially going to take this point and we're moving it 2 to the left. Then we're moving every other point here 2 to the left so we can get our new absolute value function. And so it's going to look something like this, is what we're dealing with. In question B, it says the graph of y equals g of x is shown. Translate it to get the graph of y equals g of x minus 4. When the constant addition or subtraction is being attached after the function and not directly to the x, in this case to the g of x, this is going to be a vertical shift. So this is a vertical shift. And in this case, this is a vertical shift that is 4 down. So our second graph here, we've got this parabola, and we're going to move it 4 down. So 1, 2, 3, 4. We've got our points there. Maybe we find a few other nice points. This was close. 1, 2, 3, 4. Close enough. 1, 2, 3, 4. And then we get the general idea of what our parabola is going to do. So we're seeing a shift of 4 down. Here we've got the graph of y equals the square root of x. Translate it to make the graph of y equals the square root of x plus 4 plus 2. So here we've got our transformation taking place underneath the square root. So this is going to represent the horizontal shift. And this 2 here represents the vertical shift. So with that, we're going to be moving 4 to the left. 1, 2, 3, 4. And then up 2. And we can do that for other points. 4 to the left, up 2. We can do it for a few more. 4 to the left, up 2. And our general shape of our graph is something like this. Here we've got the graph of y equals f of x as shown. It says draw the graph of y equals f of negative x. In this case, if they're doing f of negative x, what they mean is that we're going to reflect this across the y-axis. So basically we're changing the x values to the opposite sign. So in this case, this x value here is at negative 2. Opposite sign puts it at positive 2. Up here we've got negative 6, so we'll move over to positive 6. And now we've got our new line. In the second problem, the graph of y equals g of x is shown. Draw the graph of y equals negative g of x. Since this negative is outside or being applied to all of g of x, we're essentially seeing a reflection across the x-axis because we're changing the y value signs. And so we're seeing this to where we're going to reflect across the x-axis. So, if we're reflecting across the x-axis, this point stays the same. It's on the x-axis. This one stays the same. Here we see this shift down, and we see this shift up. And our graph looks something like that. Here, the graph of y equals f of x is shown. Draw the graph such that it's 2 times f of x minus 4. So they're taking two transformations in place here. We've got our horizontal shift inside, and in this case, and then we've got our stretch by 2. So the easiest way to do this would be to, in this case, we're going to take our y values. So this one is at 4. We're going to double it, put it at 8. And then we're going to shift this 4 to the right. So this is our new point. We've got this point here. Multiplying by 2 doesn't do anything. Shift it 4 to the right. Here we're going to multiply by 2. We get 4. Shift it 4 to the right. So our new graph looks like this. In B, the graph of y equals g of x is shown. Draw the graph of y equals g of negative x minus 3. So here we're seeing it reflect across the y-axis as well as a shift of down 3. So let's take this point. We're going to go across the y-axis. It doesn't have to move. It's on the y-axis. So we just move down 3. Then we, for this point, going across the y-axis would put us up here. Then we go down 3. 1, 2, 3. So it puts us here. And then this point, oops, I messed that last one up. Go back. Sorry, this point, we're going across the y-axis, so we should be going this direction. And then down 3, 1, 2, 3. So we're looking at this point here. So we'll get rid of these other points that we don't need now. All right. And then we've got this point. We're going across the y-axis, so we go over to 4. Then we get down 3, 1, 2, 3, and we end up here. So this is our new graph. Here it says below is the graph of y equals x squared. Translate it to make the graph y equals x plus 3 squared plus 4. So we've got a horizontal shift of 3 to the left. 1, 2, 3. And then we're going to go up 4. 1, 2, 3, 4. So this would be the new point reference. We go from 0, 0 to this new point. Then we can go to other points on the graph. So here we go 1, 2, 3, and then up 4. Puts it here. Then we can go from this point. We'd go 1, 2, 3, 1, 2, 3, 4. And we'd be there as well. And so we get a general idea of what our parabola should look like. So here's a good concept summary of transformations for functions. You've got a reiteration of your vertical translations being the addition of the constant k to f of x. Your horizontal translations, you've got the addition or subtraction of your constant h to the x within the function f of x. Your vertical stretches and compressions, where you have your a value being greater than 1 is a stretch, your a value being a fraction less than 1 but greater than 0 being a compression. And then here you've got your reflections here. And remember, if it's a reflection in the x-axis, you're seeing that it's a negative f of x, where if it's a reflection in the y-axis, you're seeing the negative x within the f of x. I would add this to your notes as a very good particular piece of the puzzle to have with you, especially as you're conducting these transformations.